comfortable. Yeah, it was 3 minutes, but we're live. Good. Thank you. Wow. Good room. Let's go because I have a full list of slides. So PHP in the graph, mostly about with Gremlin. Anyone has been using Gremlin already? One? Okay, so you're all beginners. You start from nothing, right? Good, I can tell you anything. And okay, I think we have a very young audience. If you want one on the elephant, I can sacrifice one. But anyway, so we're going to talk about Gremlin, which is one of the languages to actually go into a graph and learn and extract data from it. So that's exactly what's on the agenda. I'm going to start working on, well, presenting the graph itself, at least how we organize closer to the. I thought it was time. You want me to do that? It's already pre-impressed. Better? No, it's not going to be. I don't know. Bonjour à tous. Ouais? Okay, we're still live, right? Okay, anyway, so first part of the talk, I'm going to tell you about the, well, if I have slides, I guess. And no. Oh, that's a mess here. We talk about discovery of the graph, presentation of the graph itself. So you have the basis of the element. That's going to be very easy. There are two elements. There are nodes and there are edges, or however you call them. And then we're going to dwell onto the most interesting part, which is how to traverse, how to handle this big blob of data. Okay, it's not going to be like SQL where everything is nice and clean. Okay, column values and everything is understood in it, right? Everyone does that, right? Okay, here it's a big mess. So we're going to see how to move like that. And I will finish by Gremlin and PHP itself, meaning that whatever I'm going to present you now, well, if you want to use it from PHP, of course, well, you need the link at the end, and I'll just show you at the end. So we skip the installation and the dirty, greasy details for the end. For those of you who don't know me, I'm the proud owner of the first elephant ever. That's my main achievement in life. I just, haven't torn it. I've been doing PHP since the last century, and I'm probably the most, I would say, negative of a Belgian that's possible. Yeah, je parle pas wallon, je parle le français. Ik spreek Nederlands, not Flemish, very badly, but whatever. And I live outside the country, so probably you take me, put it in a photo booth, and then you get a Belgian guy. So just the contrary. Anyway, how come do I end up with working with Gremlin? Just because of that, I do for a living static analysis. So I don't even run the code you plan to run, but before that, I actually try to review it. So initially, I did that on my own, with my little hands, well, with my little eyes. I realized it was way too much. Okay, currently it's like 3 o'clock, so I probably have already reviewed 2 million lines of code since this morning. The machine is working for that all the time. So basically, it takes a piece of PHP, just break it into tokens, and rebuilds the links there is between the lines of code and what's really happening. And you think a little bit about it. It's not a table. You can put every if in one table and the switch in another one and the method calls in a third one. That's going to be a mess. You need relations between all those elements, whatever artificial they may be, and you want them into something that you can query. So that's exactly the experience I have. So one thing we're going to work on, and that's why you're going to hear me listen and mention WordPress a lot, is that we're going to work on a very simple graph, which is the WordPress call graph. Okay, I chose WordPress because it's mostly functions, so you understand it's kind of easy. You take one function, the function has a name, so that's what I'm going to collect, and from there I know what are the other PHP functions that are being called. Okay. No namespaces, so that makes the whole of it very simple by itself. Most of the PHP function has been removed, so we won't have anything that's alone like that. Okay? Anyone understands what we're working on? Right? Okay. So if you understand what you're working on, then you're going to understand that. Because what I've shown you before, that this precept of linking a function and its a function call on the definition will end you up with that. So it's very easy. You can see there are nodes and there are links, but they are a little bit. So how do that's actually the usual experience I have. Okay, I think about turning a network into something that I can understand, so I collect that, and the collection is usually kind of easy, because here, what do I need? I need to tokenize PHP code, so there is the tokenizer extension for that. I collect the strings, I put that in, I just select the ones that are important, and I put that in a doc format, and that's it. And then I try to understand what's there, and I don't know, right? I don't even know what to start with. Okay, it may be arbitrary, but when you look at a SQL table, then you start at the top. ID 0, ID 1, something like that. Here you don't have that. Where is it? Where is the number 0? I don't know. So we need a traversing language, and that's actually the definition for that. Traversal language, something that helps you navigate through the maze of the graph and will actually provide you with interesting data. That's what we want to end up with. Okay? And the one I discovered when I started looking for something that was not SQL to support my static auditing was Gremlin. It was, I don't know, like 4 or 5 years ago, something like that. It was in version 2. And we're going to work only on version 3 today, which is the current version since a year or something. So what is important? So first, it's a domain-specific language. So it's going to work only for graph. Okay, you can apply that to something else. We will actually see how the concept can actually ooze into PHP. That will be the conclusion. It's a programming language. Again, I'm going to compare that with SQL. It is not something where you feel you have templates and you just fill a few keywords and you get some data. No, no, we're going to work. We can have variables. We can maybe not declare classes. That's going to be overkill, I guess. But we can do lots of things. We can have loops. We can have variables, incrementations, filtering, things like that. So that's the important part. It's open source. The code is online. It's actually on Apache incubator at the moment, so you can go and download it. It's vendor agnostic, so also we do not depend on one database. Okay, it's more a standard as for that as SQL. You can apply that to many different databases. There's a list of them at the end, so when it's important to know that, you'll have the list. So the letters are here. G is V and E. They're actually the first thing that is actually kind of stressing when you start is that the vocabulary is not the same. Okay, so when we talk with Gremlin, we have graph for G, E for edges, and V for vertices. Simple enough. Vertex, if there's one. Okay, it seems like it's some kind of Roman language, and edges. You may also have people talk about nodes, links, and the data set, or also objects and relations and the data set again. Okay, so suddenly it's two, 3 different words for the same reality. Okay, be ready for that. It's not the only situation where you'll end up with the same concept applied to different realities. So be ready. We'll try to stick with this one, although I've been learning that myself on my own, so I usually mix them. Please switch them from one to the other. First actor we have, well, we'll use the G here. That will be a recurring gag. G for graph, maybe for Gremlin. I don't exactly know which way it represents, okay? But it's the default one we have, so we'll always start the query with that. And the first one are the vertices, which are the nodes, the object itself that are in the database. The big dot, red dot, no, black dots. You've seen in the first ugly cloud. That's it. We have that. What can we say from that? First, you get it. The full list of them is accessed with this method. And if you just want one of them, every single node has an ID. So just like databases, all of them get one. Okay, the edges will get another one. But you start with that. If you ask for it, well, you get it, and you don't get anything back. Okay. What you see here is really a method call. Okay, I have a first object, which is kind of special. We're not going to go into it any moment. We'll just wait for the rest. The rest are methods, and we're going to call methods. Each method are going to be linked with the preceding one, so a method will probably return an object, a vertex by itself. Okay? No details yet. Of course, we're going to be able to go into the details, but that's what you want at the beginning, the first one. If you want to go inside an object, well, the graph, most of the graphs are schemaless. Okay, so you can put anything you want inside an object in terms of properties. So if you ask for the object, of course you get the object itself. If you want to go inside the properties, they're called values. And you can have the usual suspects in terms of value type. So strings, booleans, integers, reals, arrays, which is nice. So we can store full arrays in them. Arrays of arrays, again, that can be interesting to have. But you can have them, and you don't care if it's defined somewhere or not. Okay, you can always create one, destroy one. If it does not exist, it will return null. So in the time you end up with a null, then you're probably going to stop the whole query anywhere. So for example, if v1 does not exist, then it's a null. The rest will be done, and we end up with a null at all. That's the finish. Easy enough to that? Nothing surprising, right? Okay, so let's move on. If you want to do some discovery, and again, when you're a beginner, that's a really useful tool. Value map. Okay, you've seen that values will give you all the values itself, as long as you know the name. If you don't know, you want to discover what's inside the graph, then value map is going to return you everything in JSON format. Is it? Yeah, no, I don't know. Anyway, in an array here, it's interesting. Here I move to another value. You can get the whole list or even just one of them like that. So in terms of discovery, when you don't know what's in there, you can start with a value map. That's an important. Our second culprit here, the edges. Okay, so we have the object. We now have to link them. That will be the work of the edges. They are stored conveniently into the big E methods. You can access any edges by its ID, which also has an ID, and the two of them are separated. Actually, we won't care about that later. Okay, but there are two separated of them. Two of them. There are two separated sets. And the only thing that's special about edges is that they always, well, they have three things. They can have properties just like we've seen for the objects. Okay, same stuff, properties, it's the same values. So when you're crawling on the space, you can always, check something along the edge. They have an ID, they have a start, and they have an end, which are integers, which are the previous IDs of the nodes we've seen previously. Okay, and they also have a label. So that's why I put here calls. That's the one we're going to use. They always have a label. Okay? Nodes can have a label, but it's not compulsory. They can have the same label for everyone. That's good. If they have different labels, then they will be probably indexed differently, but that depends on the lower underlying server. So up to now, it's okay. Nodes, we are okay. Labels, on the other hand, they always need a name. Shall we put them together? Yeah, of course, we need that. At some point, we'll have to do that. So edge discovery works exactly the same. On top of that, ID, so values for everything except for IDs and labels, which are used by the language itself. Okay, they get a special method by themselves. Otherwise, when you get an E like that, it's an edge. If you get a V, it's a vertex. If you get a null, it's nothing. And otherwise, you get an error. So, shall we put that together? Yeah. Now we have the edges. Now we have the object. The meat of Gremlin is, of course, to navigate through the network itself. So here is a very complex network. Okay. Suddenly we have like 4 objects and 3 links. I use the different IDs here, so we make the difference. I don't want to say, oh, this is edge 1 and this is linking the vertex 1. No, they're all different, but they probably, if you do that on your own, they will probably have 1, 2, 3, 4 and 1, 2, 3. Okay, that's normal. So from the edge, we said we know the outgoing link, so we can ask for outv, meaning I want the outgoing link, and I need the vertex, and we end up on 2. So we say E5. E5 is this link. The outgoing is the one there. Okay, the ingoing. That will be the start. It will be on the other side. Okay? This is called a directed graph. By default, all the Gremlin graphs are directed, meaning that there are always a starting point and an ending point. Okay? In general, you can have directed or indirected graph. So if you don't care, well, you just use out just as you like. We'll see another one to do the movement in a moment. And there is a way to do the migration, the movement from any side. So the graph is good, but just information in it. So on top of that, following from an edge. So we've seen how to reach the edges of, well, the limits of an edge. If you are working from a node, then you will start with a V, and instead of out V and in V, you'll get directly out. Out and in, we'll just say, okay, if you follow the link that are going from this link, then you'll go, tell me the list. You can see here from G1, the incoming link, the incoming nodes from to 1 are only 4. So I just get one result. Is it easy? Yeah. I like to see nodding heads. On the other hand, you can have several links, right? So if you want the out ones from V, coming from V and going outside, now we have 2 and 3. And if you want the whole of them, you use both. Fair enough? And then you can get the list. If you really want to go inside the link and make some checks, then you can also mention the E. Remember when we go inside the E and we want to go to a V, we have out V and out in V. Now, if we are in V and we want to go to reach an E, then you change the layer. Okay? Now, I think that's probably an epiphany when I was starting to work on that. That's the chaining. Then remember, I told you that, well, G is the start. That's bringing us a node. That's bringing us another node. So actually, we could start chaining them. Okay? So let's say we want from the H2 and we want to see what is the ID of something that is in and in again. Okay? The first GV, I start with the ID. Then I go one way and I go another one. And I end up with the number 4. And I can chain. And I can go 1, 2, out, V, both, explode, and start counting. Okay? I end up with a number. Okay, so I mentioned this is the graph, this is a number, this is a vertex, another. I end up with a number because here ID will say, okay, at that node, once I have found a node at that point of the traversal, I stop and I look into the node and I get a number. I cannot go on with another in at that point because it's a number. I'm stuck. I'm in a property. There's nothing more I can do. Okay, we'll see later how we can extract something along the way. Yes?
How do you know how many ins you have to write?
Here? Oh, it's just an example. We're going to move to something that is a little more, I would say, business-like. Okay, we're going to move inside the database, the WordPress database. That's going to be more interesting. There you can start thinking. That's more example. Yeah, it's going to be different. So, remember, you want to have a schema. Okay, it's schemaless because we don't have any properties. If you want to remember the WordPress call graph, that's what it's going to look like. And actually, on top of that, I should remove one of the function, right? Okay, because actually we have only function types and this link. Very simple. So how come do we end up with that? Okay, I think I got 4,400 function definitions, and I got something like 55,000 calls on the current version. Does that make sense? 44, yeah, for the current version. Does it make sense? Like 4,400 functions in WordPress. Yeah, it's a pretty large piece of software, right? Including all the functions, I mean, all the inclusions they have, all the external libraries. Kind of makes sense. They're using roughly, each function is, as a mean, it's used 11 times. Okay, so what can we find something interesting in that? So first, if we just convert, no, not one call. You don't use all of them all the time, right? Hopefully. Well, come to me, I'm going to reconfigure it. So the first, yeah, this if we start going, yeah.
So if we see any nodes without any edge, that means that we go to something.
For example, yeah, it could be. It could be the function is still here. WordPress itself do not use it, but it's still there because they have previous version for which they want to provide backward compatibility, and that's it. How, well, it's way too early for me to answer that, but let me think. When I reach the point where you can answer that, I'll ask you the query. Okay?
Just a question.
Yeah.
So in WordPress, because you actually subscribe to hooks, and you put the functions like strings.
Yeah.
So you take into account those as well?
No.
No.
For this example, no.
No, okay. Because there are plenty of those.
Yes, there should be. I have to admit, here I needed a base with enough data, so it could be fun and interesting. In the same time, I didn't check all the PHP special cases. So yes, you're right, and that was actually in my first slide. There is one where they say, okay, apply filter, and there is a name of a function.
Exactly.
This is not taken in case here, but we're not going to we're going to use it to navigate.
Just for the picture.
Okay.
So it's more, in fact, links.
So the simple version, if we make it really large and just take a few elements, then we have one functions which have incoming calls. So those other functions may call this function, and this function in its turn may call something else. Okay. So if we want to just have a look at that on this exact example, again I start with an ID. I'm still stuck with that, but that will go away. I go out 1, 2, and I get the name. So I get those function names. And I can call the incoming functions on the other way. I'm not using out because this is a directed graph, so I know which way they're calling. One function is calling the other, or the function is being called. I can know all the functions that are calling VP set password, for example, by using the other one. Okay, just application of what we've seen. Okay, so now question, would you imagine that WordPress, okay, yeah, let's move.
How about if you have recursive functions?
I don't know what you're talking about. Now we're there. Now we're there. You know what? Please, take over. That's good.
Sorry.
Can we detect the number of WordPress, or number of them, of WordPress functions that are actually recursive? What is a recursive function in our graph?
In and out are the same.
In and out is the same. So that's interesting. We can start there, get permalink, it calls get parent, good, but this is not the same. So that's not a recursive function. Same stuff from the other way. What do we need here? We need to find a function that calls itself. Okay, at that point, you know how to move along the graph. You know you're able to go very far, but you don't know how to stop. So we need a little few more functions. Here are two of them. What I have on top, well, GV is okay, out is okay, values are okay. What you need is two of them, which is as and retain. So the one we actually need directly is retain. Retain means that I will only let things go if it's the value that is provided here. Okay? So this is a filter that says, if you give me a list of elements, I will only let those pass. And here, I need to tell it which elements have to be passing. So I first name my element. So I start with something. For example, I start with this one. Say, okay, that's myself. Now I go out there, and I say, oh, is it myself? No, it's not myself, because I named this one, and I can understand that, and that's not the same. So I stop. Okay, so I start again. I go there, start 30. Okay, this is this one. I go out. Here, it's not myself. Here, it's myself. So I can go on, and I end up here. Then I got my name, and I display the name. Does that answer the question?
Yes, thank you.
Okay. I don't remember how many exactly I found. 5 or 6. Does it make sense to have recursive function in WordPress? Yeah, why not? Of course. First, why not? There's no reason to be just a little surprising. Get category parents. This is for menu. Yeah, menu. Typical usage of things. Things we call each other. Well, the submenus will call the parents, and the function is the same. Yeah.
What if the recursion is over a chain of arbitrary software?
Come on, you've talked together, right? Wait for a slide. Because in between I have to show you that. The one we have done here, we said, okay, we start with this, we follow the call, and we end up there. But it's a directed graph, and we can move on the graph the way we want. Okay, if we can do that, then we can actually rewrite the same query and build it the same way, actually, but go it with the in instead of the out. Here is the same, okay? Here I call the origin, or I call the following. That's the same. Now you have this question. Could you find what I call ping-pong table of functions? Okay? It's like, hey, oh, I have that. Hey, send you that. Oh, that's interesting, but hey, that's for you. Okay? Ping-pong function. How can we do that? We need an extra word. We need an extra filter that will actually filter things that are not ourselves. Okay? From what we've seen already, we know everything except. Oh, that's a bad transition. Thank you. The two of you are following. So we still have the retain. So what we want to do, we start somewhere, we call, and we don't want a recursive function. Okay? A ping-pong function is something, or two functions that are sending them each other probably the same value. Hopefully not the same, but they are calling each other. Hopefully they will stop at some point, right? But we want the first one not to be himself, and on the way back, we want it to be the same. Okay? So the first one, we start with 47. We call it, so we know what to compare it with. Go out, not me. Again, out again, me, and then I know my answer. And this will give me directly at least two answers. If there are none of them, that would be 0. Otherwise, I will get 2 of them. But actually not starting with that. Okay, anyway, if we don't start with the 47, then we'll get 2 of them, because if this calls that, then the contrary is good. So, third guy, next question. So, ping-pong function. So I actually found some. If we go on, we can do that with 3, right? Yeah, that's what's easy to guess. I can do that with 4. And I can do that a long time before you get fed up, right? So what do we need there? We just Yeah, it's fine. I got 2 of them like that. So we can actually chain again, right? The first one we don't want it. The second one we don't want it. The third one, maybe we could actually name the intermediate one, so we don't end up with recursive functions. That could be an extra thing, but that will probably go out of the slide. So we go on. That could be nice to have a loop. So yes, there are loops. There are loops in Gremlin, which are conveniently called repeat. They work with a subquery. So we are going to put between the parentheses something that we want to repeat. We mention times, so we know how many times we want to repeat that. Here, 3 times. We can also have an until some condition is met. This is nice. So this first call that really shrinks the size of the query. The other thing we have here is the emit. Emit itself will just emit anything that passes through. So as long as I can run into that, the repeat will repeat itself. Okay. When it's done, the emit will say, okay, this value has been found once. I give it to you. Okay. If you put init in the emit another filter, except myself, well, it's already there. But we could put except myself and not emit the thing. Okay. So we can do something in the loop. So the body of the loop may be complex. And when we end up at the end of the loop, we can have another condition for the emitting. Like we just want the end of the loop, or we want to emit anything we find in between. That's interesting. And you can also put emit here or before. Then it will start immediately emitting. So it will emit the first one, like a do while. And otherwise, it will just repeat it once. No, that's the contrary. It will be a while, right? And otherwise, you can put it behind, and it will just repeat that after at least running it once. That's convenient, right? Can you do that in SQL? No. Yeah, no. So what have we seen up to now? Well, we've seen the node on the vertices. We've seen in and out, which is the backbone of your navigation. You're going to use that a lot. We've seen a few filters, except, retain, in, without the label, that's going to come, and the first loops. So now we're going to move to something more interesting. I'm still waiting for your question, right? But basically, traversing the graph is architecture around that. We're going to say, if I follow those, okay, I follow I start with a node, I follow that, and when I end up there, the whole story, if it's matching, then that will be my query, and I want to extract some data from that. That's exactly the chain I want to find, okay? I want to find one query that calls each other, or that calls itself, okay? That's exactly what we're doing. We just follow the path, and then at some point make filters. If anything ends up at the end of the query, that's our result. So filtering, we've seen a few of them. Another one that is really convenient, I think, and I really like that, is that you can actually add the extra label in the edge you're moving on. Okay? The example is not built for that because I only have one example, which is one edge, which is core. Okay? Imagine that you have classes instead of functions. Okay? There will be classes instantiating, there will be inheritance, there will be extensions, extends, and implements, for example. So different relations between all those tools, okay? And we can put all of them into those and say, okay, I want to follow and find an interface. I'm just going to follow implements, not extends. Except if I start with a node, which is itself is an interface, because interface has to be extended by another interface, extending another interface, while classes will be implementing an interface. Two different behaviors, okay? That's a good one. If you have more than one, then you can put them just in a row. That will work also, just the same. I'm going to use that a lot, so that's kind of needed. Hello, Internet. If you want to filter on vertices, there is the as function. The first one says, does this vertex has a name? Whatever it is it defined? Is it not null? If it's not null, then it will pass, okay? If it's null, then it will not pass, so it's not defined. Otherwise, you can put one value. You can ask it for it not to be the value. And those NEQ, you're going to see a few of them, are what they call predicate. They look like functions, and you can apply them. So here, not equal. There is another one which is equal. There is smaller, larger, things like that, all those operators. Strangely enough, there's supposed to be a regex one, if you want that. But I've never seen it on Neo4j. For example, it depends on the server, on the underlying server. So there's a few of them, but not all of them. Within or without. You have a long list of elements. You can say, okay, if the name is in this list, then it works. But that will be filtering. That will be filtering on nodes. Let's say we want to look for dying functions that may end up calling vpDie. Okay? What do we get here? So notice that we don't know which are the functions. So we start with v. I don't put any ID anymore. Okay? ID was initially good because I wanted to start from a point of view that you understand. Now we just say, okay, in the whole graph, any of the verges, you follow one, and if it must end up on the function that is called vpDie. And then you show me the name. What do we get? Yeah, vpDie, of course. vpDie, what is important here? Basically, the query looks like that. I start with something, everything in the data set. I follow something, and I end up with vpDie. And then there, I say, okay, I want the name. But the name that I really want is the one at the beginning, not at the end, right? So the processing is important, okay? Since we're chaining, things are flowing through the pipeline and the whole query, then, yeah, we have to be careful. So how do we do that? Yeah, we run the opposite way. So we start with the function that is called vpDie, then we go inside, and then we find the name of the function. And there we have a list of interesting things, okay? So the graph is going one way, but we don't care. We have all the means we need to do it the way we want, okay? So let's use it this way, okay? Actually, here, for this example, it's kind of simple. You could actually end up with that situation. Initially, I used that, and I didn't really care about the order of the query, okay? So here we have the two of them, and I introduce you with your good friend count, which makes sandwiches, as you all know, right? So it's counting the number of elements. And I say I start with V, go out call, end up with bpdi count for 84. If I do the other one the other way, I also get 84. Because count just end up counting the number of things that go through it. So it doesn't care if it's several at the same time, okay? It was laughable for us to end up with all the names because they were all the same. But they are actually different results. He found another way to end up on vpdi, and that's how we need to count. So at that point, one thing you want to make, if you want to make the difference, is by adding dedup. Now dedup, can you guess? Deduplicates, yeah. I have no idea why the hell they only decided to have this one as abbreviated name. Usually they have long, a human readable name, okay? And the first time I got that, like, dedup, it's like, what this is, like, okay, yeah, deduplication. So, yeah, we have, I think there is another unique. Okay, let's answer that. Okay, I think we'll see that later. There is a little problem for that. Maybe the deduplicate will be the same origin. I don't know. But this is the only one that has an abbreviation. So here I say, okay, get a function you follow. You end up on vddi. You dedup. So you only allow one instance of an object that has reached this point, and then you count. And of course, we end up with 1. Okay, so no variety. On the other hand, if we do the same with several of them, then you have 84. I wonder if the usage of dedup as a really ugly name is not made for one good reason. Here, it's a beautiful name. Is that your name, maybe? No? Okay, no, that happens. Here, what happens is that we scan everything, we follow, we end up on die. We actually end up with 84 elements, and we just say, okay, I just want 1. So we do a lot of work. We unearth, we find everything, and then we end up on that. On this one, it's a lot more streamlined because we just find the one we want, follow once, and the first hit gives us directly all the results we want. We don't need the dedup. It's completely useless. And we just manipulated 84 data. Here, if you have a million line to analyze, that's going to be a lot longer. So anytime you start using dedup, what? You have to be faster. So on top of that, we've seen counting. So here is the count. There are a bunch of functions interesting. Limit, okay, like in SQL. Range is the SQL limit, but with the beginning and the end. Okay, so you can get numbers. Tail for just the end, so that's interesting. There is coin also, which is nice. Just going to make a sample of that. Just completely arbitrary and random. Okay, the number you have here is a percentage, so we get basically a % of the element. Which means that you can make, you want to test a query, you don't want to run it on the whole database, directly coin. It will just make a number of them, like once in a while, just going to give you a few data. So dying functions, back to the start. What do we need? Just rewrote it to introduce you with my good friend select. We've seen again the as, remember? Okay, so I still use the out because it's interesting. What happens is I give the name of the element that's interesting me. I go out, do some checks. When I'm done, wherever I end up in the graph, then I say, okay, select start. If you reach that point, if from there you can go out, find a vpdi, then when you're done, stop, come back, and get the thing called start by name. Okay? So the keyword here is select. Select will actually, at any point in the query, will move the cursor, if we call that, move it again to a place that has been named, a place you've been there. So you can go, find an interesting node, go one way, come back, go another way, come back, do a third way, and then end up there. And in the same time, collect lots of interesting information. Okay? By here is not actually a functions. It depends on the previous method. Select, and there are a few others, which may not mention by heart now, but select will say, first name will be displayed by name. So I mention a property, we'll display that property. I can actually say start, mention 2 of them, and have 2 different properties selected from there. Or I could select several values, give them different names, and each time select, okay, the first one by name, the second one by ID, the third one by, I don't know, extension, whatever that means. So select and as actually work a lot better than that we've seen. Okay, but yeah, that's exactly what I'm explaining. So let's imagine, 10 minutes, what do I need? Okay, let's finish with this one, the subqueries. Okay, here's getting a little strange. I'm trying to look for functions that are calling both escape HTML and VPDI. So someone that probably preparing some error messages, and then we'll actually push that to VPDI, something like that. So since from what we've seen, okay, we start with the name, we go on. The first one has no constant, but that will be our result, so we name it. Okay, we don't care about what's the result, but that's on our way. We go out, check the other function call, and then we select the result. So we know exactly the one we get from the middle, right? The order of processing is from here, because we start initially with the VPDI, and when we end up with the escape HTML, right? So we do not start from where we want, and we do not end up again from where we want. We just have to use select to move everything back to the right place. Unless, of course, you use higher level gremlin. There is another function called where, which allows you to do subqueries. So you moved on the main graph, and at that point, you don't want to divert and have gremlin go somewhere. You just want to do a little check on the side. Okay, that's exactly where. Here, where, say stop and go out, find a call if there is a VPDI. Okay, if you find something where anything, a number, a node, an edge, where will be happy, it will be considered a true. If it doesn't find anything and end up with a null, then it will be a false and will stop. Okay, so basically I can now start from anywhere. Here, do a side, go to VPDI. Oh, I found it, so I go back. And of course, we can do the same for the other one. Okay? And that will now look like that. Oh, and that's a miss. That should be an in, right? That should be an in. Where the hell do I have to add that? And that would be answering the question about dedup, possibly. For out, actually, that's another typo. I just start with out, and that goes, While on the other hand, when I start here, I have to start with underscore, underscore. Underscore, underscore represent the current node, okay? Which could make sense here. I could use underscore, underscore, but here, as a sugar syntax, I don't need it. Here, and that's really puzzling when you really see that initially, is that because, well, that should be in here. In is actually a keyword for groovy. Who the hell is groovy? Yeah, I mean, did I mention that up to now? Yeah, you have to show me another 5 minutes, right? Yeah. Actually, this engine is written on Groovy, so most of the code we have here, we have a programming language, will be based on Groovy, and Groovy has a keyword which is in. So we cannot start directly with in. It doesn't have a keyword called out, so starting with out is okay. But starting with in is not possible. So we have to use underscore, underscore. This is there where we start, seeing the limit between the language, the gremlin language, and the underlying. There will be, I think they just published a C implementation of gremlin. So possibly in this C implementation, in will not be a keyword, and that will flow. So suddenly the standard is not exactly the same for everyone. Let's finish. If you want, oh yeah, our good friend count. So if you want to use a where and end up with something that is a negative assertion, then use count and you make it equal to 0. And that's probably another typo. So let's finish with that. That's the full idea when you're writing a query with this language. You think about the way you want to traverse, then you think about the different conditions you have. It may be on the node, it may be on the side, it may be a little back trip, a side trip. And in the end, you mark in red the one you want reported. And that's how you end up with a gremlin query. Yeah, so to finish, I'm sorry, I'm going to jump that. There's filter, which we start using actually Groovy code, okay? In the closures, and there's a very interesting group count, group by, just the same as in SQL, but there's a group count. What I really enjoy with that is that you can have several group counts in the same query. Because actually the group count is just a counter. It just, okay, I get a node, I get a specification in it, I know what I want. I want to count the names of the function, so I collect that and I put that in an array. But I can do something with that, right? So I just show that to the next one. And the next one is another group count, which is now counting the number of times this function is being called. And I end up with one result and two different group counts at the same time. That's an interesting one. So, PHP and Gremlin, okay? Well, first of all, you can see that PHP is a lot better at logos than them. PHP for Gremlin, there is POM vert. Do not mistake that with POM. It's completely different, right? Yeah, great. So this one is POM vert. Gremlin PHP, it's on the Composer. So okay, Composer install, you have it. There's a lot of old stuff for Gremlin 2. Make sure you start working Gremlin 3. Gremlin 2 is completely dead, but there's lots of servers running with it. So make sure that the one you choose is the one running. For example, OrionDB, which I will mention in a moment, is still running Gremlin 2. It's not what I've shown here. And they are going to move to Gremlin 3. It's on the way, but it's not done. Okay? So just make sure when you make your choice that Gremlin 3 is the one that is being supported. Otherwise, from Neo4j, there's a plugin which uses a REST API. How does that look like? Require once, use, connection with the host and the graph being used, open, send, get the results, close. Someone hasn't understood? Okay, so that's very simple. From PHP point of view, it's very simple. I say that the meat of running the query is rebuilding them. Okay, maybe fetching a number of information from your own PHP before putting that in the query with the usual injection problems, unless, well, no one's know how to use a Gremlin, so maybe we're safe for a moment, but that will happen. Okay. So here the version is 3. There is Gremlin. Initially, I think there's one of those projects. It was initially 1, 2, 3, 4, 5 projects. Okay, 5 different projects that were processing different parts of the graph, and they from version 0 to version 3. You skipped the 10 minutes. Thank you. So each iteration, one of the project was merged into, and finally it's only Gremlin. So just look for Gremlin, or you can call that, it's currently called Tinkerpop. Okay, it's an incubator on Apache. You will find the information there. Now, as I said, Gremlin runs on different databases. I don't know if MySQL or MariaDB done it. The guy who wrote Gremlin wrote Titan, so the integration is pretty tight. That's a good one. The stable ones I use for Gremlin from Neo4j, but Neo4j is running the show with Cypher. So initially, when I came, Gremlin and Neo4j were very good friends, and it was easy to set up. Okay, I have to admit that I came to them with that. Nowadays, more and more they're separated, so it's getting more and more difficult to use Neo4j from Gremlin and vice versa. But it still works, so it's okay. Stardog, I don't know. Tinkerpop has a server by themselves, and Rexter is the old server from Gremlin 2. Okay. One thing you have to understand: there is a server. The server itself will be the one that installs the underlying servers. Okay. So there's a Gremlin servers that you will tell it, okay, install TitanDB, and you will be using TitanDB. At the beginning, it's a little confusing. I'm expecting to be Gremlin on top of that, but it's not the contrary. There is a Gremlin server which turns the query into something that's the underlying server understands. That's the way it works. Okay. So basically, you have to download the server, the console, which you will be using to input your data, and the server itself will run. There is an easy install from them, all in command line, and you have to use this command line. Okay? And there it is. Well, thank you for staying with me. Yeah, let's move. I'm staying, well, I have to go, right? Yeah. Oh, 3 minutes for questions. But I'm staying here, so if you want some more answers, I'll be able to answer. Yeah?
Can I analyze the performance of the queries somehow? Like, are they like or quadratic or like even higher?
Okay, I'm going to say no. I'm going to say no. The reason is Gremlin is the top level language, and it's actually relying on the server to do the actual performance thing. So let me give you an example. Anytime, do I have a query somewhere? Oh, that's not an easy one. Okay, anytime I start with that, for example, based on Neo4j, for example, just behind, instead of in and out, I make a label check. Okay, I check if my node is of a certain type. I have different types of them. The thing is, Gremlin do not do any optimization for that. So it just says, okay, as label, good, and it shows that to Neo4j. Neo4j, on the other hand, the first time it sees the as label, it says, oh, do I have an index for that? Yes, then I check it. I have no way to create the index using Gremlin because Gremlin do not understand the index concept. I actually have to rely on Cypher. So when I set up the database, I call Cypher to build the index, and then it will be used. But from Gremlin, no, there is no tool that will tell you, okay, you should do this way or you can do another way. The other trick I use is, as usual with databases, the less amount of data I manipulate, the better it is. Okay. So after the GV, for example, or the first check, I put a counter. Okay. I mentioned that you can include the closure. Okay. Groovy. So I use a little side effect. I didn't show that, but there's side effect. So I run a little counter. And when I'm done at the end, I end up with another counter saying, okay, here is the number of data I processed. Here is the number of data that I have in the end. When I have too many of them, then I usually go back and say, okay, is there a way that I can make that faster? But at that point, no, this is the problem of the separation of this standard and the implementation. Sorry for the long answer.